At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Welcome, everyone. Let me get this shared. Can I get a quick confirmation that I'm sharing the correct screen?
Yep, you are sharing the presentation.
Perfect, thank you. All right, welcome everyone to the Simio Solution Series 2025. Let's get into it. So today's session, March 19th, is Building Blocks of Simio Modeling Part 2. Hopefully, if you're here today, you either attended Part 1, which was a month ago, or you watched the recording of Part 1. That does not preclude if you did not see that. It does not mean you couldn't be here today, but hopefully you were in attendance for Part 1. If you did not see Part 1, we do ask you or welcome you to go watch it. It is on our website, and I'll show you very quickly how to get to prior sessions. But don't leave today if you haven't seen Part 1. So my name is Dan Vasilini. I'm the VP of Global Sales here at Simio. Doing most of today's presentation is going to be Kiara Bondi. She's one of our solution engineers. You can see both of our email addresses right there on the screen. I will flash these up at the end of today's presentation, just in case there are questions you might have that don't get answered, or you want to reach out to us directly. That'll be the way to get a hold of us, through one of those email addresses. And like I said, I will bring it up at the end just in case you're either not here now or you didn't write these down. So on the screen, you'll see the QR code there on the left-hand side. You'll see this one more time during the opening. If you could open up your device or open up a device and scan that in, basically looking for some feedback on both today's session, prior sessions, as well as any type of suggestions you may have on future sessions. We're always looking for customer feedback. So please feel free to scan that, give us some feedback on today's session, as well as, like I said, any type of futures. All right, a couple more slides on my side. A couple housekeeping items before we get started today. Please be aware that today's session is being recorded for replay purposes, as mentioned. If you'd like to go back and watch or rewatch this session or any prior sessions, simply visit Simio's webpage, simio.com. You see a little picture on the screen there. On the resources tab on the top right, first drop down is Simio Solution Series. Any of our prior Simio Solution webcasts are there. They're all recorded. So we have dozens and dozens of those at this point. We've been doing them for three years now. So you've got dozens of options to go back and watch. We have them categorized as far as beginners, advanced, intermediate, etc. So please feel free to go in and take a look. You are going to be muted today during today's session. If you have a question on the WebEx dashboard, probably on the right side of your screen, at least that's where it's at on my side, there is a QA area. Simply type your question in there. Those come directly into me. And what I will do during today's session is, if a question is very pertinent to a topic that Kiara is on, I will try to interrupt her, or at least jump in when I can to ask the question based on the subject. If the question is more generic in nature, then I will hold that question to the end. We usually try to save about 10 minutes at the end of the session for Q&A. I know last session, the Building Blocks one, we did go all the way to the end, but that's because there were a bunch of questions throughout the presentation. So we kind of did the Q&A up front versus at the end. So please feel free, ask some questions along the way. Upcoming, so as I mentioned, this is part 2. Part 3 is going to be just about a month from now, 23rd of April. That'll be our last of our introduction sessions here in 2025. So we had intro part 1, or our building blocks part 1, building block part 2 today, building blocks part 3. And then we will be planning our sessions after that in May and beyond. But prior to getting into the future sessions, let me just go into real quick, just an announcement on Simio Sync 2025. So for those of you that aren't familiar, Simio Sync is our annual users conference. We have been doing this for many years now. It is a live online content session. So you will see presentations that from our customers from Simio. They will be recorded. We will have live Q&A for the presenters in most cases based upon time zones. But that said, we are officially accepting registrations for Simio Sync now. It just went up live, I think, 2 days ago. So I know you can't click on the link on the screen where I have the Simio Sync registration. So I put a picture on the right-hand side as far as how you get to that. And then when I am done presenting here, in the QA box, I am going to send the link in general to all participants. So you will be able to click that link right there if you'd like. But I mean, it's very simple to find. Just go to simio.com. You'll see very right-hand side of the screen there. The Simio Sync registration page is open for anyone to register. It is a free event, so don't think there are costs or anything involved with it. So please get registered for it. We look forward to it. Generally, we are just finalizing our content now with our end users and customers. The session will probably be 9 a.m. Eastern time, running through mid to late afternoon with half dozen to a dozen presentations throughout that time frame. So please feel free to get in, get registered, get signed up, and we're looking forward to another great conference again this year with great presentations. All right, lastly, I do want to thank you for coming out here today. There's the QR code that I mentioned earlier. Feel free to scan that again. It's your second chance to do it. You will get a third chance at the end today when I flash the email addresses up for Kiara and I. I know Kiara is going to jump right into presentation mode. I don't think she has any PowerPoint to go along with it, so she'll be getting right into the modeling. I think, will introduce kind of the piggyback from last session into this one, and then jump right into her. So thanks everyone again for attending. Be on the lookout in the QA side of the box. I will paste the link for Simio Sync. Otherwise, we will be here the rest of the time. Kiara, the session is yours.
Awesome. Thanks, Dan. Hello, everyone. Thank you so much for attending. As Dan mentioned, this is going to be our second session of our 3-part series of how to get started with your first model, from starting with the software and just getting more aware and used to where all of the different features are, where the objects are, how to place them, how to modify some of their properties, to, in this session, kind of looking at how to add a little bit more detail, leveraging some of the other features of the software, including tables and table references, which we'll dive into. And then in the next session, diving deeper into results and kind of those advanced analytics and options available to you. But with that being said, I'm going to jump straight into the model. And so we're going to be building off of the same model that Adam had worked on during our previous session. So I just want to make sure, Dan, can you confirm that you can see my screen?
Good to go, Kiara.
Okay, wonderful. So this is the model that Adam had built in the very first session. And so if you haven't seen that, I highly recommend after this session, go back and see kind of how we got to this point, how we were able to use the servers and set up all of the different nodes, the objects, and then all of the different routes for it. But when we left off on the session, there were a few points that we wanted to sort of work on in terms of adding a little bit of detail, and then we'll be picking up exactly from there. So during the last session, we introduced routings. So the routings done through data, which you can see right here through this table that we built, allow us to define for different products. So in this case, we'd have the 3 different widgets, where they need to go to complete all their tasks. This is very helpful when trying to model specific sequences of operations and the different stations that products would need to undergo. For example, if you know that something needs to go through a coating, drying, and then cleaning sequence, or a specific set of tasks that need to be performed at different locations, you can use these tables to define all of that. But not only can we define the routings, for example, or the destinations of these locations, we can start to add more detail to these tables to help us, for example, define the processing times. So we know where they need to go. We know that they need to go to, for example, the widget A would need to go to turning, milling, and then finishing. But maybe we want to specify, okay, well, how long is this product going to be at turning? How long does it need to be at milling? Especially because if we have different products, each one might have a different processing time. Maybe widget A will take less time because it's smaller and lighter and easier to work with than widget B at the same station. And so in order to do that, we can actually use the same table right here to then add to it a new property to help us define its processing times. So for our case, we can use, for example, if you have a specific processing time for a consistent time, so say you already know it's always going to be 5 minutes or 50 seconds, etc. We can leverage the real or integer properties to just define those specific values. Or if we want to add some sort of randomness and variation to our model, we can use the expression editor and then use this to define our processing times. And we can specify then in the properties right here, all of the different units. So in our case, for example, we know that this is going to be the processing time. So I can go ahead and specify that the unit of this property is going to be a time-based. And then we can say, is it going to be represented in hours, minutes, etc. Process time. And so here now I can start to, for example, add my random expressions that I'd want my different part types to process for. And so to do that, for example, if we don't recall or remember the exact syntax, we can actually go back to one of our machines and see what the process time here, for example, was, and use these editors to then say, okay, what are my different options? So random, and then dot. And you'll see that in this, using this syntax, you can see all of the different options for different random expressions and distributions that we can use. So for example, I can just take whatever was here before. So I can take this exact expression and I can copy it over and then paste it into here. And then maybe I can make it so that there's different distributions, maybe random, uniform, etc. So once that's done, what that would look like is something like this, where we have a new field to represent all of our different processing times. And so now, whenever our products go through the system, they'll have a reference to not only know where they need to go, but thanks to these references to the table, they will also know, okay, well, what is my processing time at that particular stage? And a great way to test this is if we start running the model, and we'll start seeing all of our entities getting generated and going through the system. So here's a few. I'm going to run it just for a little bit longer. And then if I pause, now that a few have continued, a great way to check and make sure, okay, did my processing times, are the entities staying in those machines for as long as I expected? We can actually use the Gantt chart in our results to then see, okay, how long did my different widgets stay at their stations? Now, we saw these Gantt charts during our previous session when Adam showed how we can use these to make sure that all of our entities are going through the route sequence that we had defined. But we can also use this again to then make sure when we're looking at, for example, okay, how long has this been for? We can see, okay, this has been here for 1 minute, 6 seconds at finishing one. So does that represent for widget B, how long it should be there? Well, it should be there between 0.8 and 1.2 minutes. So having been there for just over a minute makes sense, and it's representative. Same thing, if we go to milling, for example, we can see it's been there for about 13 seconds. And if we go back to the data, milling, it's between 0.2, 0.4, 0.6 seconds. So that would be between 10 and 40-ish seconds. So seeing this being here for 13, again, makes sense. So one thing that we'll note though here is if we look at processing times, we'll see that the finishing stations are going to be the ones that take longest. And in fact, we can see that in the data. If I, for example, filter down to finishing, we'll see that these would take a little bit longer than our other stations. They'll take about a minute, maybe a little bit more, whereas the others will take less than a minute, maybe even less than 30 seconds. So having all these different processing times, what we might then start seeing if we kind of run the model still further, oops, I ran it a bit too fast, but what we can start to see is some entities building up in the different queues and having to wait, especially here, for example, for a lot of for the same machines, for example. Why are all of them just waiting at milling 1 when it seems like milling 2 is available? And the reason for that is with how we've defined routings. So from last time, we saw that we can specify whenever we have a different selection, we can do a select from list. And that allows us, whenever we get to a specific node, to then look at our different candidates and then pick where we go. But right now, we're just picking these randomly. And so what that potentially could mean is, as we saw here before in the milling, if I again fast forward, we can see that all of them randomly decided to go to the same milling station versus potentially going to the one that's available. And we can actually see this as well of if all of the different queues and the routings are balanced in our results. So we can leverage not just the pivot grid to then start to see, okay, where are all of the entities going and how long are they staying there? But then we can actually use the pivot grid to then see, okay, what are my different waiting times at all of my different machines? So if we clear out, here we go. There's some filters here. So I'm just going to start clearing these out so we can see all of our different machines. And at our servers, we can start to see, for example, at the input buffers and output buffers, the different waiting times. So if I filter down to my server and then filter to the inputs, oops, and then holding time right here, just so that we can look at that specific value. So we can start to see that there's a few that waiting, for 4 minutes or even 10 minutes for the different machines, etc. That's, that can be long. That can be maybe not what we're looking for, especially at the finishing where it seems like it's significantly longer and maybe not as balanced. So for example, right here, to help with this and ensure a more balanced sort of transition, what we can actually see in our nodes, in our different options, is whenever we select from a list, we have actually quite a few options for saying, okay, how do we want to, here we go. Sorry, there we go. So we can actually then decide and start to see, okay, what are our options here? So as we can see here from our list, we have a few, the selection goal right here is what helps us define, okay, how do I pick which node to go to? So again, let me just fast forward as I had modified this before to the finishing results. But we can see now these queues for the finishing machine are significantly longer when we randomly select where to go. And in fact, if I go into the results, we can start to see for these specific machines really high waiting times for the buffers. It seems like we are just overworking all of these different machines and we're not being sort of smart on how to allocate them correctly based on our processing times, for example, or machinery availability. Because as we saw before from our routings, some of these entities might take a little bit longer than others to process. So we might be better off sending them to the available machines and having a little bit more order with how we distribute these products accordingly. And so to do that, we can actually change our selection goal to meet our criteria. In some cases, we might want to pick the closest machine for a travel standpoint so that we don't travel as far. Or the largest, maybe we want to make sure that we put everything farther away that is, for example, shelf stable versus something that's not that's perishable. But in our case, what we actually want is, for example, to pick the machine that is least busy. So the smallest value for the machine's associated station load. So you see that this value expression has a default setting to it, which is candidate.node.associated station load. Now, just very quickly, what this syntax is telling us is when we're looking at a selection of lists, it's saying, okay, from all of my different options, so candidate is that first syntax, and what are your candidates? What are your options? Well, those options are nodes in this case. So that's the candidate.node notation. And then the dot associated station load is the syntax or the expression that allows us to see, okay, the node is associated to some sort of machine in our cases. How busy is that machine? I want the least busy machine possible. And so when we start doing this, what this is going to allow us to sort of pick whenever entities arrive here is to not just randomly select a finishing. We're telling them you can't just randomly pick one. You now have to actually look at your options and then see which one is least busy and go to the least busy machine. So if I put a breakpoint, let's look at this, and I fast forward to the first one, it's going to go to the first finishing machine because none of them are busy, right? They're all available. So it's just going to go to that first one. But now this next one, which we should see is it not go to finishing 1 and go to finishing 2 or 3. And in fact, it goes to finishing 2. And now this next one, again, we should see only one available option for it because these are busy and this is the least busy one. And in fact, that's what we see. And that will allow this then to balance all of our machines and all of our different processing times to minimize these queue times. So now we've seen how we can add detail to our routes. We see how we can add a little bit more detail to, for example, our processing times to specify, okay, we have all of our objects, maybe processing at turning for an average of, 1 minute. But what if that 1 minute is actually split up across different tasks? What if we wanted to get even deeper in our understanding and say, okay, I know that this is going to be there for 1 minute or 2 minutes or however long, but that is actually distributed across maybe multiple different tasks and multiple different options. Well, there's 2 ways to go about this. We can actually go into all of our different machines and then specify a specific task sequence. So all of our processing can actually be either defined by a unique processing time that's defined by this. And you can see here, in our case, it can either be an expression straight in here or setting a reference to our tables. So table routing processing time, which is right here. Or we can actually specify task sequences. And in these task sequences, if I then open the repeat group, we can then add however many tasks we want to represent in that machine. So we would specify the sequence number in sets of tens. So this would be the first task, this could be the second task, and this could be the third task. And then within each one, specify, well, what is its name, what is its processing time, etc. And just like we can reference a specific expression to a table, we can actually reference multiple these properties in the repeat group in a table. So if we go to our data and I decide, okay, I want to create a task sequence table. How do I go about that? What kind of properties do I need? Where do I even start? Well, in Simio, if you actually expand on these add tables, and you'll see there's a few different options. You can add a normal data table. You can add an output table, which is going to be where we can actually record information. And this is going to be explained in much greater detail in our next session. So if you want to understand. Yes.
Real quick, when you are the task repeat group window, we cannot see that, just so you're aware.
Oh, okay. I apologize for that. Let me actually then change the view just so we can all see that. So let me do that. Okay, so can you see Simio again?
Yes, I can see Simio.
And can you see now the window?
Yes, there you go. Perfect.
Okay, excellent. Apologies for that. This would be the repeat group where we can specify all of our different tasks and specify, okay, this would be task 1 with sequence number 10, task 2 with sequence number 20, and then task 3, sequence number 40. We can add as many as we want. But as I was mentioning, we can actually do this also by setting a reference to a specific table. So how do we go about creating that table is we can actually use different schemas. So you'll see here that actually in Simio, we provide sort of different schemas or different pre or ready-made tables that have all of the fields that you would need for a specific type of table with information. So if you wanted to create a table for your bill of materials, you wanted to create an inventory table, etc., you can see that here we provide all of these different options for Simio to then allow you to already kickstart that table by saying, okay, if you wanted to create a table for inventory, these are going to be the basic properties that you're going to want to use. But for us, if we scroll all the way down, we'll see that we have task sequence. And if I click on this, it gives me a few options for what kind of schema I want. And what I want is I want the schema for my repeat group of tasks. So I can see that I can do this and then click OK. And then Simio will create a table named table tasks with ID, sequence number, name, branch type, process name, etc. A lot of different properties that I can then, if need be, add to, or if I don't need certain properties, I can remove them. And so it's in this table where we can now specify for all of our different routings, for example, we can specify, okay, for this specific routing, I want, these number of tasks, etc. And in order to do that, we're going to be reusing primary and foreign keys. So we've already used them here, as you can see, by defining our widgets as a primary key and referencing that in the routings. But just very briefly, again, just to reiterate what these do, what these allow us to do is interconnect different tables based on a specific property or field. So these allow us to identify unique values, in our case, the unique different part types that are moving through the system, and then connect them to different tables so that we have a very specific reference specific for our, in this case, part type. So that the widget A, for example, can only see its routing, widget B can only see its routing, and same thing for widget C. And we can use different key or the same key referenced in multiple tables. So if we had something for the tasks, we had something for maybe material requirements, we can then reference that specific widget. So what we're going to do in a similar manner is creating a new key to then reference in our task so that we have a specific reference to, okay, which part of the sequence am I in and what will my task at that point be? So what we're going to do is create a, I'm going to use a string. And what I'm going to do is set it as a column key. And as you can see right now, it tells me error, 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 because duplicate key values, i.e. there's currently nothing, so all of these are duplicates. And the important thing to note is when you're defining a primary key, each value in that key column must be unique. So although here we're referencing widget A multiple times, because it's a reference, we can do it multiple times. But in the products table, there's only one widget A. There can't be multiple. So now here I can start creating my, let me change this to be my key column. I'm going to just call this key. And now I can name these, for example, widget A turning, widget A milling, and just keep on going. And what that would look like is if I go here to my next table, okay, we can see that I've created this new field. I've called these widget task 1, 2, 3, specific for turning, milling, and finishing, for example. Once I had this key defined, what I then had to do is, okay, I have this key, where do I want it to be used? And where we want it used is in the task table. And so in that task table that we had originally built, so this one right here, we can then add, as I mentioned, different properties for other fields that we might be missing. So for example, you'll see that this table, for example, doesn't have a processing time expression. So we can add the expression for our processing times, just like we did in our routing table. So that routing, this specific field, we can actually then copy those values and use them here. And then we can use a foreign key to then let reference our routing key table to then help us understand, okay, at each routing step, this is the specific task that I will be performing. And once we fill out all of the fields, again, adding all of the names, so again, doing task 1, then, if I just task 2, and then continue on with this, we will get a complete table right here with all of our different unique names. And then if I expand upon it, all of our different tasks. So at turning, for example, we can see that widget A is going to actually perform 2 different tasks. And we can specify, okay, well, what is its processing time? What does that look like? But maybe you think, okay, that's great. I have this table, but how do I actually then use this table? How do I reference this table? And so if I go then back to that previous model, just so that we can see it in this specific field, let me just remove this so that we don't see those errors down below. There we go. And then let me remove that as well. Reset that. Excellent. So you might be thinking to yourself, okay, well, do I need to now go into each individual task and somehow set a reference to everything here, etc.? And the answer is no, we do not have to do that. And the reason for that is because just like we can set for each individual processing time here, so if I actually reset this just to show that, we can right click and then set a reference to our processing time column that we had created. If I define this as a task sequence, I can actually do the same thing by setting a reference to a full table. So if I actually set that reference to my task table, I will then see that I can't add or delete fields. I can't add tasks, but right here, my model has already understood, okay, there's a table that has my task sequence and my task name and task branch, etc. I'm just going to use that. And similarly, we can, as I mentioned, there were a few fields that were missing, but we can then add them to then add those references directly here. So for example, I added a reference in my table to be tasks processing time. So now I can do that. And we can add more. We can specify material consumption. We can specify resource requirements. We can specify quantities for each one, etc. And so thanks to these tables, we're able now to add even more detail to our model. Not only are we able to say, okay, yeah, I know that, at each turning machine, at each milling machine, at each filling machine, etc., finishing, excuse me, we're using this set amount of time, etc. But I want to get a better understanding of how that time is distributed across my tasks. This is the way to do it, using task sequence tables to then add all of those different operations. So we've been talking now for a little bit about tables and sort of adding these different tasks, etc. So Dan, are there any questions that have come through that we can address now to discuss any of these points?
Yeah, so I think these might be relevant for now. Can processing times be dependent on, for example, the entity's dimension, or if processing batch products, the batch size, or other properties?
Absolutely. So just like we can use these expressions to reference, for example, or use them to reference a random function, so random.triangular, random.uniform, we can actually use them to also reference specific properties, whether those be properties specific to the entity itself or properties specific or generic to the model. And so what that would look like is, say we had for each product, this batch size, and we wanted to take that into consideration. Well, what we can do is in our tasks for our tables, we can actually, for example, if we wanted to say, okay, this is, it's typically that time times that the batch size. So what we can do is in our expression, we can actually then use math notation. So the asterisk for multiplying, addition, subtraction, etc. But we can then add our syntax to reference the different tables or properties to then modify that processing time based on whatever other field you wanted. So for example, if we wanted to reference our table products for the batch size, we can do table products dot batch size. And now, because again, the use of primary foreign keys, our entity will have a reference to this row. So it'll know, my batch size is 4. And then in our task, it'll be able to say, okay, the processing time for this task, for example, is a random value times this specific property. And this is referencing back to that table, which we already know what that value is thanks to the use of keys. And this again can be used instead of maybe referencing a table if you had a specific property for the model entity. So for example, priority values, you could do model entity dot priority, which is the syntax for defining an entity's priority. Or if you created a model entity property, for example, you could reference that as well.
All right. Can servers perform multiple tasks simultaneously, Kiara?
Yes, so that is actually a great question. And servers can perform tasks following a specific sequence. So for example, we can see that here that we have 10, 20, 10, 20, 30, but we can actually use a dot notation as well to define, for example, tasks occurring at the same time. So let's take a step back actually first and say, okay, you've put this table, but how do I know that you're actually performing these tasks? Well, we can use the Gantt chart to, again, be able to actually visualize this. So if I go and fast forward for a model, and I go into my results, and in my resource, Gantt, you'll see all of the different tasks. And you're like, okay, well, this has been here for that long, but how do I know that the tasks are actually being performed? Well, we can actually expand on that to start to see, okay, here are all of my different tasks. So for example, for turning, for widget B, if I see this, let me actually just filter down to this one entity so that we can see it better. We'll see that we can actually expand on the time that it was there, 46 seconds, and at the bottom, we'll see what tasks are being performed. So for example, here we can see turning one primary and then turning one secondary. What were those tasks? Where did those come from? They came from our table. So if I go to turning and I say, okay, I'm looking at, let's actually go over here. So we're at widget B turning, so right here. And if I expand on this, we'll see that there's two different tasks, primary and secondary, or turning one primary, turning one secondary. And if I go into my results, we'll see, turning one primary occurs first and turning one secondary occurs second. And we can actually then compare, just like we did before, do the times match, etc. But maybe I want these tasks to actually occur at the same time. Maybe these are two tasks that can occur at the same time. Well, the way that we would do that is to actually modify the sequence number for these tasks. So right here, the 10 and 20 are specifying, okay, first we complete this task, and then we complete this task. But if we wanted to say, okay, we actually can perform both of them at the same time, we can use a dot notation of 10.1 and then here 10.2 to say this is going to be my first, let's say, branch, And this is going to be part of my second branch of tasks, both of which can occur at the same time. And so what this is great for as well is if, say, we have, you know, a task that then must be performed after 10.1, but maybe not necessarily after 10.2, we can then use this to then specify, okay, well, what's the next of this 0.1 sort of branch? So if I wanted to add a row, I can say, okay, well, this is actually 20.1 for the operation widget B task 1. This is gonna, you know, I can add a specific name. So maybe this is turning 1 primary B, maybe our primary B task. I'm gonna say this is gonna take, you know, 30 seconds, or not 30 seconds, like half a minute. So there we go. So here we go. So now if I stop and then rerun the model, here we go. What we should see is you can actually see that turning 1 primary and secondary can occur at the same time, but then that third task that I added did not even start until that primary B, or that turning 1 primary, was finished. And again, if I say, okay, actually these are 3 different tasks that can occur at the same time, I can say, okay, well, this is going to be then 10.3. This is going to be my third simultaneous branch. And if I, again, just run the model and go into our results, we'll see all of those occur at the same time. Excellent. So the resource Gantt is a great resource for visualizing sort of what happens at the end of a simulation, or when we pause a certain the model, for example. The pivot grid is a great resource for then visualizing some of the results and statistics at the end of the model run. And as we'll see in our next session, we can add even more visuals to see what happens at the end of a model run through dashboard reports, creating those really nice custom visuals to get a sense of what happened at the end. But maybe your thing is, well, I don't want to wait until the end. What if there's certain values? What if there's certain properties that I need to see right as the model is happening, just to make sure that things are moving in the way that I want, just to make sure that I'm actually seeing the values that I want to see, and I'm seeing the results that I'm expecting, I'm seeing the numbers that I'm expecting, etc. Well, there's a few ways to actually do that during the model run. So one of them is, just like we can see the entities themselves. So for example, if I go for project home, here we go. So we have a lot of different windows for analyzing, checking, debugging, etc. And all of those are provided all up here. So last time we saw, for example, the properties window. When Adam went through the model to modify some properties very efficiently for all of our different machines, he was able to use this window to then specify, okay, I'm looking at my servers, and I'm going to go through and modify potentially one of these ranking rules, define the processing times, etc. But another great window to use to your advantage is actually the watch window. What this allows us to see is specific properties and values and states that change during the model run. So we can pause and start to see, okay, well, what is happening? So for example, we might be curious to see, okay, what if I want to keep track of how many entities have entered my shipping or have exited sort of my system? Well, what we can do is if we click on watch, and then I run the model and just very quickly pause it, we'll see that if I right click on my machine, on my shipping, on my sync, excuse me, we'll see that there's a lot of different options that pop up. And one of them is actually the ability to watch. And if I click on that, you'll see that this popped up down here. And if I expand on my object, there's all of these different states and functions that I can then look and see, okay, how many units of capacity have been allocated to the specific machine if we're looking at a station or a server. If we're looking at, for example, resource reservations, we want to make sure, okay, is my machine actually seizing the worker or the resource that I'm expecting. What was the last item that I seized, etc. We can actually use this to then look during the model run as the model runs and pauses. For example, what is happening, what is going on, what's gone in, what's gone out. So in our case, we might want to look at, for example, the sync, the input at that entry, and then look at this entry queue. So if I fast forward to the end or to here, we'll see that something has hit that breakpoint. And if I now step, excuse me, let me just scroll down here for a second. I'm looking at the wrong one. I apologize. I was looking at something else before. Excellent. So through these different objects, now we can start to see, okay, well, what if I wanted to keep track, for example, for the input buffer or my inputs, how many items have gone in? So for example, we can start to see with the functions, if we scroll all the way down here, a number of items, we can start to see, okay, 2 have gone in, etc. Or different properties, such as these are Booleans, these are expressions, etc. But again, just like we are, having to pause and stop the model to use the watch window, which is again a great resource, we still need to, run the model and then pause it and then run it and then pause it to know, okay, well, what are we seeing? Which can be a little bit annoying if we're trying to see multiple values, multiple states, and changing pieces. That's why in Simio, we actually allow you through the animation tab to add dynamic visuals to see values and states changing over time. So what we can do is we can actually add animation associated to the specific object to then say, okay, I want a sort of visual counter that will show me whenever something goes in that adds to that count. So that could be, for example, a status label to see, okay, I want to use this now to see, okay, well, what is going in or how many objects have gone into my my sync, how many have exited. And so the syntax for that, for example, will be shipping dot input buffer, and then you'll see here number entered. So this is going to say, okay, how many objects have entered the input of our machine, of our sync in our case. So now if I click run, what we'll start to see, let me actually speed it up a little bit. We'll see this now dynamically change. So this is very helpful so that we can actually see and keep count of, in our case, how many items are exiting. But we can use this, for example, to say, well, what if I want to make sure that my mix of products is balanced? I want to keep count of how many of the different widgets I've created and then see how many of those I've then destroyed by widget part. Or you want to see, okay, I want to keep count of how many entities are in each finishing station or in each milling to make sure that this is all balanced and that we're not, overworking one of these machines, for example. We can add all of these different visuals, whether that be through specific status labels where we show just one individual value, or we can actually add floor labels. And these we can actually use to highlight and show multiple different values. So in this case, we could use this, for example, to show per, say, product, how many we've created or how many we've destroyed, or other properties specific. And so that what could look like is something like this, where we have our status label right here associated to our shipping, and we see the input buffer number entered. But then I've added 2 different floor labels, and if I go into the different window, you'll see the specific syntax here. This is described up here in our text sort of notes on the top here of how you can add different expressions, what kind of syntax you need to do. So if you wanted to reference a very specific Simio expression, you would have to do it inside of these brackets. But you see here that I'm counting, for example, the widget A population, the number created, widget B population, number created, etc. And then in this one, I'm seeing, okay, well, how many have I destroyed, for example, for each one? And if I run the model, we'll start to see these actually keep track. So then at the end of the run, if I wanted to say, or just keep seeing, okay, am I creating, as I've expected, more widget A's than widget B's or widget C's? Am I using this correctly? We can start to see, okay, I am producing more widget A's, and then that's the most, and then I'm producing least, which is widget C, and that is reflecting my mix. And then if we wanted to just be double certain of what we're seeing in terms of, how do I know that this is accurate? We can actually then go into the data or in the results, excuse me. And if I look at my A population, we'll see that the number created for A is 12, 7 for B, and then 2 for C, which is exactly what we're seeing here. So we could go back and see in the results those values, but if we wanted to get a more real-time dynamic visual, adding these plots or adding these labels, and if we wanted to add plots, etc., can be a great tool for checking and ensuring that your model is behaving in the way that you'd expect. And so thank you so much, everyone, for attending. In our next session, the next stages of this would be, we've added all of these different visuals to see kind of what's currently happening, but what if I wanted that information stored in other locations? What if I want to now level up my understanding of our model by getting into the different analytic options and what I can actually get from these models and what I can actually see? Well, in our next session, we're actually going to dive into all of those different concepts, understanding how can we record information, how can we set ourselves up to then get a deeper understanding using some of the pieces that we've already seen thus far, the Gantt charts, the result tables, these status labels, etc. But how can I then use these to then get a much deeper understanding of what is happening currently and how can I best move forward from here? So thank you very much for attending.
Perfect. Thanks, Kiara. So we do have some questions here as we are winding down. But before we jump into the couple of questions that are out there, I know we have a couple minutes left. One thing I did want to reference, there were a couple points that you were talking about, Kiara, that I just wanted to highlight for anyone that's watching this either live or watching on recording. We do have in-depth sessions on watch, trace, debugging, etc. of solution series we've done in the past. So when Kiara was talking about a few of those little items and just kind of not necessarily breezing by them, but touching on them from a high level, we do have 45-minute to hour presentations on exactly those topics. So if you are working on something and you want to look at the debugging side of it, we do have a full session on debugging that was done a couple months ago. So please make sure you are looking back at prior solution series on any topics like that. All right, a couple questions before we wrap here. Can task sequences be used to model tasks that only happen sometimes? For example, like a changeover.
Absolutely. So if we go into the data and I go into my task table, you'll see that there's this property that's called branch type. And there's a few different properties here, but two of them are conditional or probabilistic. And these can actually help you specify if tasks occur based on a specific condition. So maybe you want to check for rework. So sometimes you'll perform a task, sometimes you won't. Or probabilistically to then maybe support specific mixes where okay, well, if we know that in this machine, there's a 50-50 chance that we'll have to undergo an extra task that takes up more time, do we have the bandwidth to actually take that on, or do we have to figure out another way to support that operation? And so we can specify those, and then in the condition or probability column, we can then add, whether it's a condition. So if it's a condition, we can add that expression to check for true or false, or probabilistically, if we wanted to just add some sort of split or mix or probability value, let's say.
All right, I think we have two more questions in the queue. I think we can get to both of them quickly here. Do we need to set the reference to the task table every time we want to create a new server to follow tasks in a table? For example, I have 100 machines all following a set of tasks defined in the same table.
That would be really annoying if we didn't set up a method for you to do that more efficiently. So the answer is no, you do not have to do that every single time that you create a new machine. So if you wanted to add a new milling machine, you do not have to necessarily create a new server and then here say, okay, well, this is the processing time. Let me sequence and set the reference, etc. What can be done instead, and this will be expanded in further detail in the next session, but what can be done is you can actually take these objects and say, okay, I know that I have this specific milling machine, and I know that every milling machine that I have is going to have the same properties, the same work schedule, the same task table, the same reliability logic, etc. And so what we can do is we can actually create custom objects that will then have all of these properties that we've modified as a default. So what that looks like is if I then create a new object, and maybe I call this my milling. Two things we'll notice is the first thing is that these properties that in this machine, for example, are in bold because they're different from the default. In this new custom machine, they're now no longer bold. They're the default. And another thing that you'll note is that the object type is no longer a server, but it's now called my milling. So I've now created a new custom object that represents every single time that I want to create a milling machine. And so now, if we look into my library right here, I can actually see it pop up as an object that I can click, drag, and you'll see placed with the same visual and the same references. So this is how you can actually expand your models from maybe a single line or a single machine to multiple lines or multiple machines in the most efficient way possible.
Nice. Nice. All right, last one with a minute and a half to go. A preference thing. When do you recommend using a task sequence as opposed to a simple processing time?
So the answer to that is always going to be it depends. And the reason for that is it'll depend on what kind of information are you interested in. Are you really focused on the individual tasks at hand and the material consumption at each task? So for example, if you have to consume paint and then a specific task and you want to keep track of when that's occurring, how long each individual operation takes, the drying, the painting, etc., then yes, I would recommend using a task sequence. But if your question is, I know that I'm really focused on worker allocation and labor, and I know that my workers are going to be at a machine for 15 to 20 minutes. I don't really care what they're doing there. I'm not super concerned about what individual tasks they're doing there. I just know that my workers are going to be busy for about 5 to 10 minutes at this specific machine. Well, maybe there, that level of detail of what exactly are they doing is not really necessary because your focus is not on the task at hand. Your focus is on the general timing. So the question there, whenever you're thinking of, do I need to add a task sequence or not, is what is the goal of this model right now? Am I analyzing those tasks to get an understanding of the machines and the machine operations, or am I more focused on something external and the machines are just kind of another factor to it, or that processing time is another factor?
Great. And with 5 seconds to spare, Kiara, you did it. You answered the question in time. Let me very quick grab the screen back. Just go to PowerPoint real quick, just in case someone was not here at the beginning and they have a question they'd like to ask. Let me just bring up the slide here with our email addresses. So you should be able to see my email address as well as Kiara's. So if you have any questions that weren't answered today or you want to reach out to one of us, feel free to reach out this way. dvasileni@simio.com and cbondi@simio.com. And then as I had brought up at the beginning, the QR code on the left side, if you can give a quick scan of the QR code and give us some feedback from today's session, as well as any type of future recommendations you may have, please get back to us and let us know. And then lastly, if you weren't here at the beginning or you zoned out when I was talking, Simio Sync has been announced. Here's how you get to it. May 14th is the date for it. We encourage everyone to get registered now. It's a free event online. Will be some great content there, and we should be able to announce very shortly here who our presenters are going to be and what they're going to be talking about. So thanks again, everyone. We look forward to seeing you again in just about a month, and we will see you then. Bye, all.
Thank you.